Let us evaluate the integral of cosecant to the power 6 of x. When dealing with an integral of cosecant and the exponent is an even number, you would want to factor out 1 cosecant squared first. So this would be cosecant to the power of 4 of x multiplied by the factored out cosecant squared of x dx. The next step would be to transform the remaining terms into their trigonometric identity, which is cosecant squared of x be equal to cotangent squared of x plus 1. So we can condense this into a cosecant squared of x. So this would be cosecant squared of x raised to the power of 2. Note that this value is simply equal to that. We just rewritten it, multiplied by the rest. And now we can transform cosecant squared of x into its identity, which makes this the integral of cotangent squared of x plus 1 raised to the power of 2 multiplied by cosecant squared of x dx. The next step would be to expand this expression. If you recall, a plus b squared is equal to a squared plus twice of ab plus b squared, wherein a here is cotangent squared of x and b is 1. So by this formula, the expanded expression would be cotangent to the power 4 of x, since a squared is cotangent squared of x squared, is cotangent to the power of 4 of x, plus twice of a, which is cotangent squared of x, multiplied by b, which is 1, plus b squared, which is 1 squared. This is our expanded expression, and copy the rest. And now, we can see here that we have a lot of cotangent, so we can actually use u substitution here. Let u here be cotangent of x, and taking the derivative, it is equal to negative cosecant squared of x dx. Isolating the x, it would be equal to du over negative cosecant squared of x. By substituting all these values, you would have an integral of cotangent to the power of 4 is equal to u to the power of 4 plus twice of cotangent squared of x is u squared plus 1 multiplied by cosecant squared of x and multiply it by dx, which is equal to du over negative cosecant squared of x. You can actually see now that cosecant squared of x would cancel each other out, and you are left with a negative sign here, in which you can actually put outside the integral, which makes this negative integral of u to the power of 4 plus 2u squared plus 1, and what's left here is simply du. And now you can actually integrate this one by one now, since what you're going to do here just now is simply power rule formula. So this should be negative, and multiply it by the integral of this first part. The integral of u to the power of 4 is simply u to the power of 5 over 5 plus twice of the integral of u squared is equal to u to the power of 3 over 3 plus the integral of 1 of du is equal to u plus c. Distribute the negative sign among the inside part. So this would be negative u to the power of 5th over 5 plus 2/3 multiplied by u cube. This should be negative. Minus u plus c. And so your final answer would be consisting of putting u back into its original form, which is cotangent of x. And so your final answer would be negative 1/5 multiplied by cotangent to the power of 5 of x. I just put u in like this part. Minus 2/3 multiplied by cotangent to the power of 3 of x minus cotangent of x plus c.